In match problem 2, we still want to take derivatives, partial derivatives, but now what we have is a more complicated expression. In this case, we've got a composite function, x squared plus 2xy is being raised to the fifth power. So to take the derivative of our function z with respect to y, again means the same thing as finding f sub y. So the derivative of this will be 5 times x squared plus 2xy to the fourth, and then times the derivative of that interior function, x squared plus 2xy. So let me just go back and rewrite this just kind of in the pattern or style we've done these with previous problems. So we've got this interior function that's being raised to some exponent, so we use that power rule first, and then we have to multiply by the derivative of that interior function. But keep in mind we're differentiating with respect to y, meaning that x squared is just a constant, so that just becomes 0. So our result here is 5 times x squared plus 2xy times, now the derivative of 2xy with respect to y is just 2x. Or simplifying a little bit, we could rewrite this as 10x times x squared plus 2xy. In part B, now we want to evaluate f sub x at x equals 1, y equals 0. So we don't want to just use this function because this was f sub y, or the derivative with respect to y. The first thing we need to do is find our derivative with respect to x. So this starts off very similarly because we still have a composite function to deal with. So we get 5 times the quantity x squared plus 2xy to the fourth power times the derivative of that interior function. Now we're differentiating with respect to x, so we have to take the derivative of this term and the derivative of this term. So that will be 5 times x squared plus 2xy to the fourth times the derivative of x squared will be 2x, and the derivative of 2xy, 2 and y are just constants. The derivative of x is 1, so that just becomes 2y. So then we'll evaluate this by plugging x equals 1 and 0 equals y into this derivative that we just came up with. So that'll be 5 times 1 plus 2 times 1 times 0 raised to the fourth power times 2 times 1 plus 2 times 0. Which then will all reduce to just 10.